Okay, this video is to go over this idea of a combination function that we're going to need when we look at the binomial random variable and its probability distribution function. We're going to take this example about high school athletes and concussions and kind of develop this idea of combinations. So we got 20% of high school athletes have a concussion during a season, their sports season. We're going to randomly select 4 students, 4 high school athletes, and ask if they experience a concussion. So this is kind of like an experiment, and the outcome is going to be they have a concussion or they don't have a concussion. And we're going to let X be the number that report that they have a concussion out of these 4 athletes that are questioned. And we're going to label the outcomes with S for the athlete has a concussion and F if the athlete has not had a concussion. So let's look at this table. We're listing out the values that X can equal, this random variable X. It can equal 0, 1, 2, 3, or 4. And let's look at what is the outcome that would result in X equaling 0. Well, that would be if all 4 that were asked said that they had not had a concussion. So that would be the result of getting all 4 not having a concussion. So 4 Fs are all in a row. All right, so we can get one combination of athletes that results in X equaling 0. Now let's look at X equaling 1. Well, we could ask the first one and they say yes. And so that would be represented by that S, and then the rest say no. Well, we could also have the outcome that it's the second one that says, yes, they've had a concussion. So the S would be the second one, and we could have it be that that's the third one. Oops. And it could be that it's the fourth one. So there are 4 ways that we can get X equaling 1. Or in other words, there are 4 combinations of 1 S and 3 Fs. All right, now if we look at X equaling 2, we want to write down what are the ways that can happen. We can have the first 2 be no, and then the second 2 yes. We can have the first and the third be no, and the other ones yes. We can have all the other combinations. So if we list those out, be kind of systematic about it. The first and the last could be no, and the middle 2 yes. We could have yes, no, and we could have the first 2 yes, the second 2 no, and then we could have the first and last are yes, and the middle 2 are no. And that gives us all the combinations. So that is 6 combinations where X is equal to 2 to say that they have had a concussion. All right, now what about 3? So we can have the first 3 are yeses. All right, we could have that all but the third one, all but the second one, all but the first one. All right, so there's 4 different ways that we can have that combination of 3 S's and 1 F. So for X equal to 3, there's 4 possibilities. And then for them to all 4 have had a concussion, one way that can happen. All right, so we get a list of the number of combinations for the value that X takes on, where X is equaling the number of students or number of athletes out of 4 that have said that they have a concussion. Now, this is really easy to do if we have a small sample size, like 4. We can write down all the possible combinations, but what if we have a larger N, all right, where we're taking a larger sample? It's something like this. We want to know the number of ways to select 15 out of 20 adults with only a high school diploma. So that is where we're going to use a combination function that we plug values into, and it gives us the number of combinations, and we don't actually have to write them down. So this right here is the actual function. Now, the most important piece here is this right here. And just being able to understand what that means. We're not actually going to use this function. We're going to use a calculator or an online tool. But this combination function is saying n is the sample size and the x is the number of the random variable. Okay, now you're going to want to find on your calculator, or if you don't have a calculator with this function, you can find some online tool, and I will have one posted on Foxtail as well. And your function may look like this, or it may look like this. I think this is probably even a little more common on calculators. And it might be embedded in a math function list or probability function list on your calculator. So you'll want to hunt that down and get a look and find that. Okay, so let's look at how we're going to use that function to calculate these number of combinations. So here we've got n equal to 20 and we've got x equal to 15. So if we put that in the notation, we're going to put the 20 kind of floating up here at the top and then the 15 at the bottom. So it's not a fraction. This is just this notation that means, well, how many ways can we take 15 items from 20 items, or in this case, 15 adults out of 20 adults. Okay, so here's where later. Now, if you have the combination function that looks like this on your calculator, the r is taking the place of the x, and so what you would plug in is first the 20, and then you would select that button or select that item from your menu, and then you would put in the x number, okay, or what they're using for r, and then hit the equal sign. All right, and what you should get is, it's actually a fairly large number, 15,504 ways. So we're fortunate that we don't have to write down all those possible outcomes. But that's how many ways you can select 15 from 20, all right? 15 different, 15,504 combinations of 15 that you are choosing from 20. Let's look at the next one. So we still have n is 20. This time we're choosing 10. So plugging that into calculator, you're going to go 20. All right, find that combination key or menu item, and then plug in the 10. And that's actually an even larger number, even more ways to get 10 out of 20 than 15 out of 20. It's 184,756. Okay. All right, we'll do a few more just to get some practice in. Let's say we want to choose 5 out of the 20. So we're going to plug in 20, our combination key, and then 5. And that gives us 15,504. Okay, so notice that's the same as what we got for x equal to 15. And when we looked at number of concussions, we got the same for x equal to 1 and x equal to 3. Okay, that's not a coincidence. There is that kind of symmetric sort of a pattern that is going to be followed. All right, now let's look at this next one. We have 20, choose 0. So how many ways are there to choose 0 things from 20? Okay, like our example with the concussions, well, there's only one way to do that. There's only one way to choose 0. Okay, you can plug that in your calculator and that's what it's going to come up with. Or sometimes calculators won't actually calculate that with 0, but there's only one way to choose 0. All right, now what about x equal to 1? So how many ways can we choose one item or one person from 20 people? All right, well, there's 20 people, so there is 20 ways. So that's always going to be the case. So it doesn't matter what n is. If we're choosing one, it's going to result in whatever n is. And then let's look at this next one. What if we have the number that we're choosing is the same as n? Okay, well that's choosing all of them. And so there again is only one way to do that. Okay, that's always going to be the case. If we are choosing the same number as there are items, it's only going to be one. Okay, we're going to use this in the section 4.3 as we develop a probability distribution function for the binomial probability distribution.